The preferred learning method is a guide for the way each child or adult is studying, the way they represent their experiences, their ability to remember the information, their word of choice. The 7 learning abilities are: visual, prefers to use drawings, pictures and space understanding; oral, prefers the use of sounds and music; verbal, prefers the use of words; both in writing and in speech; kinesthetic, prefers the use of body, hands and touch; logic, prefers to use logical and mathematical reasoning; social, they prefer to study as part of a group or with other students; solitary, prefers to work alone. Studies done with modern medical imagery show that learning style uses different portions of the brain. By involving more parts of the brain during the learning process, we are able to remember more than what we have learned, and we are able to make more connections with other types of information. The traditional school system uses a verbal and logical teaching approach. The good news is that none of these learning abilities are fixed forever; they can evolve and be trained. As educators in the school system, we need to realize that only the implementation of verbal and logical teaching methods, providing children with information that is strictly a synthetic result of general knowledge, without providing examples of how they have reached and how they can be used, can lead to a less understanding of the subject, even for verbal and logical learners. Only by employing an integrated and employing methodology, where all learning skills and types of information can be trained, we can hope to create a useful background for the development of all children. Left parietal lobes are responsible for logical thinking and understanding of information. The logical mathematical learning style refers to man's ability to rationalize, solve problems, and learn by using numbers, abstract visual information, and cause-effect analysis. Children who mainly use log math skills but can easily recognize the properties, patterns, and connections between things that may seem independent. This enhances their ability to classify and group information, which helps them understand and learn. Children who frequently use logic, mathematical skills, ensure your math problems, or any problems, in a systematic way and enjoy creating new ways of using in the future, like setting numerical goals, budgets, and tracking progress. They are more organized, they set the itineraries, they make lists and usually set their priorities before they act. Characteristics of those with logical mathematical intelligence: they can support their point of view with logical arguments, examples or statistics. They prefer to work strategically and make use of simulations. When it comes to board games, they prefer all those that require attention and tenacity, such as puzzles, tables or chess. Of computer games, they usually prefer Dune, StarCraft, Age of Empires, Sid Meier's or others. They enjoy school activities such as math, computer science, technology, graphic design, chemistry, astronomy, and more. They are natural or constructive meditators and are happy to bring mathematics and concepts to life through concrete projects such as computer design, robot building, and scheduling. Typical phrases: it makes sense, follow process, procedure, rules. There is no bubble for that. Let's make a list. We can solve it. Prove it. Typical occupations. Talented students in this field are attracted and usually succeed in careers such as programming and graphic design, electronics and telecommunications, robotics, mechanics, engineering, accounting, finance and investment, statistics, architecture, technical design, and others. Characteristics of those who organize their thinking and experiences in a logical style. They believe that logically, most of the time, they react positively to logical information. They are often emotionally affected by logical information. They seek new logical information, use logical resources to describe objects, ideas and emotions, logically encodes emotional phenomena. They try to express themselves logically. They want to know how logical concepts are called and invent the logical classification systems. They look for new logical terms or use mathematical forms. They can say when something is wrong in a certain logical style: inductive, deductive, syllogist, analogous, and distinguishes patterns or similarities. They regularly use logical tools to encode experiences, thoughts and achievements. They use the symbols of the logical systems to express their ideas. Cultural or social events are logically marked or memorized. They remind us how to organize a man during the event. They can interpret the logical form of literature, musical compositions, and can easily assimilate or imitate new logical styles. They find logical meanings of natural or mechanical phenomena such as landscapes, social events. How their mechanisms work. They think and innovate logically, without consciously transmitting. They arrive automatically or remember logical information. They see logical information everywhere. Notice the logic of arrangements before hearing music, or see how things work before seeing them actually work. Their actions are heavily affected by logical or absence. They have a logical sense of humor, find classification systems or logical evidence. Characteristics of people who organize their thinking and experiences in mathematical style. They use mathematical thinking for most of their time. They seek mathematical information, want to discover mathematical concepts, are interested in expressing themselves in an analytical way. They experience intense emotions and react comfortably to information in mathematical form. Choose to use mathematical methods to express their ideas and feelings. They can invent mathematical forms, new numbers or number systems. They automatically have mathematical information, so their actions are heavily affected by this information. They assert that the printed notation represents physical phenomena or demonstrations of phenomena. They can predict what follows in mathematical units. They discern between different parts. They play with numbers, imagine things in numbers and formations, think and innovate mathematics. They use mathematical methods for relaxation. They manage mathematical methods as memory assistants, write their notes as formulas. They are interested in mathematical information above all the information. Just like logical people, they are mathematical products. With these differentiate mathematical styles and discern patterns and similarities, additions, decrements, algebras, computation. They have the desire to share their knowledge, cultural or social events illogically marked or memorized. They remember how many people were there, remembering how each person was located in the room. They extend mathematical knowledge in new ways, such as recent algebraic arithmetic formulas. They find mathematical meanings of natural or mechanical phenomena such as landscapes, social events, modes of operation of machines. They can have physical imagination to make their imagination. They use mathematical symbols to communicate ideas. They like mathematical humor, funny numbers, or illogical. Strategies and activities that can be used at school or at home for logic math children, games or kids. For example, building games that include calculus. Puzzles, creating games that incorporate mathematical concepts, classify and rank. Getting rewards, produce life-related problems or stories. Building Legos models, making calendars, assembling artistic models, prototypes based on mathematical data, studying patterns, and modeling, studying sequences or divisions of an event number. Analysis systems, role-playing about mathematicians or scientists, computers, creating programs, graphics or computer games, creating graphics, maps, charts, symmetry study. Using concepts of statistics, probability games, problems of recognizing and solving them, interdisciplinary activities containing mathematics or logic, syllogism. Map design, planning projects, deciphering codes, game with numbers. Visiting museums or science galleries, computer and scientific fairs, researching projects, conducting scientific experiments, applying methods, interpreting data. Learning methods for mathematical, logical students. A person with mathematical, logical learning trends should discover the underlying reasons for the schoolwork. This type of person should not only memorize words or theoretical notions, but must understand the details behind the requested content that helps interposing the lesson. You should create and use lists by abstracting key text points while studying. You can also use other methods to identify important domains. Be aware of your physical condition, i.e. breathing and stress. It is possible to isolate your body through rational thinking. Remember that this is part of the whole system. The equipment you use, you cannot teach it or memorize it just by using the brain, learning with your whole body. Remember that connections work well when it comes to both logical and irrational questions. It does not matter how well two things fit. You have more chances to remember later if you have made illogical associations. Your brain can protest at first, but it works. If you write your thoughts, emphasize thoughts and logical behaviors. This highlights your ability to choose systems and procedures and the fact that you can find out when to change a set of procedures. Use your systematic thinking to better understand the links between the different parts of the systems. An important point here is that systematic thinking helps you better understand the overall vision. Often, this is higher than the sum of the parts. For example, you can understand the individual systems of an airplane and flight surfaces, but you could not have a vision of how these systems support the flight in balance. System charts can help you with this understanding. It's hard to change your behavior or habits. You can rationalize everything you want for the reason you have to change the behavior you have and the one you want to get. But it can happen that the old one persists. Try the sharp technique to understand the current and desired behavior. Once you understand this, use the deviation technique from the old to the new behavior. If you fail alone, ask someone else for help. Sometimes you can overanalyze certain parts of your learning or engaging in a skill, ability. This may lead to a paralysis of the analysis. You're busy, but do not get close to a goal. If you are too much in analyzing starting topics or in super planning course charts, stop and focus on progress. Consider how much you get from you because you've lost more time than necessary. Measure your activities according to the speed at which you have reached your goals. Planning exactly how much you spend on each theoretical chapter does not help if you are not